Hey guys, what is up? Quackware here. Today we're going to basically going over some basic recursion. If you're familiar with recursion from another programming language, this probably isn't too useful for you, but we're just going to go over some really basics, talk about what's useful about recursion, give a very small standard example, and that's it. We're just going to explain what basically needs to happen if you want to have a recursive function. So a recursive function is basically a function that calls itself. So we can just, I guess, go ahead and create a recursive function. We're going to basically create something that prints a number, and yeah, that's it. So let's do print, and we'll also need to decrement that number. So we'll do print and decrement number. We'll do int number. Okay, so basically what we need to do is instead of using, so for example, instead of using something like a for loop, int I equals 0, I less than 10, I guess this will be int I equals 10, I greater than 0, I minus minus. Instead of doing something like this, we want to be able to do this print here without this for loop. And you're thinking, oh, what about a while loop? So we also want to do it without a while loop. We want to basically do it only through function calls, and that's where recursion kind of comes in handy. It's able to take a repetitive task that you can often, separate into smaller chunks and just call it over and over again as you basically take this large task and make it smaller and smaller through repetitive calling. So a very good example of this is if we have this, say, count that is 10, and we want to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we want to stop at 0. So we could have had that for loop like we did before, or we can also do it through recursion. So let's go ahead and set up this call right here. Let's pass it in count and make sure to do get car so that the console does not go away. And every recursive function, which is this one, needs to have three basic properties. And those three basic properties is it needs basically a base case so that it knows to not call itself again. So basically a stopping case that it just returns. It doesn't actually call itself again. And it needs a way to basically get closer to that base case. So we need to go from, a large amount of data or something into like a smaller and smaller and smaller amount until we finally hit that base case. So we need a way of getting to that base case. And we need to have the recursive call itself. So a way to call the new function with that smaller chunk that we've created that is closer to our base case. So it's very, very simple to see this with this simple number example. So as this thing says, we need to print and decrement the number. So let's go ahead and do the easy part, the print. The number is, let's print out this number. Boom, we did the print part. And we also need to decrement the number. So let's go ahead and do that, number minus minus. And let's do the print and decrement number call with this new number. So right here, we've already done 2 out of the 3 things needed for a recursive function. We have the way to get towards the base case, which I will write in 1 second. And we also have the recursive function that is calling itself. You see how these things are exactly the same because we're calling the same function. Now, if we don't want this running infinitely. So if we had it like this, if we just ran this program right now, it would just run forever because it would keep printing until it probably crashed or something like that. So we need a way to tell this function, okay, I don't want to call this function anymore. I want to stop. So our base case is we only want to print from, I guess, 10 to 1. So we can basically say if number equals 0, just return. So we're not going to call, we're not going to print. We could even have it print to, so if we wanted to go from 10 to 0, we can just have it here. So this way we're not actually calling this recursive function again. This is our base case. This is where we're stopping. So there we go. There's the 3 necessary things in a recursive function. Our base case, what we do to stop, a way of getting closer to the base case, number minus minus, and the recursive function with the thing that's closer to the base case. So there we go. This is basically probably one of the simplest recursive functions you can have. And there are many really specific applications of recursive functions that you don't really like think about. So like you really need to like see it on a case by case basis. They aren't really used very often, but it's a really important, I guess, functionality to understand. But more often than not, you'll just be using a normal for loop. But for certain things like, specialized problems where you need to kind of chunk things down, certain algorithms, recursion comes very handily. I know Sudoku solving is a good example. Maybe I'll do an exercise on that later. I'll just solve a Sudoku puzzle with recursion. That's actually a good idea. But yeah, that's basically it. Very simple, Oh yeah, of course we have to test it. So let's go ahead and build this. Looks like it's built correctly, and let's go ahead and print it. Boom. The number is 10. That was it with our first call. And you see how it's called itself over and over again until finally it hit 0. It hit this return. We're done. That's it. So boom, that's a very simple recursive function. Yeah, that's it for this tutorial. Thank you for watching. Make sure to watch my other C++ tutorials. This is Quackworth signing out.